Okay, I stole this little diagram from your book, and you can look at it, but I'm just going to explain it to you a little bit because I do like it. All of these triangles, by the way, all these cases right here, here, and here, are a side-side angle, side-side angle, side-side angle, side-side angle, side-side angle. But based on how long side B is, we get different options here, different things that can happen. The first one is the one we just ended with on that other video. B is so small that it doesn't make it back down, and we can't even get a triangle, no solution. Precisely, B has to be less than A sine theta. A sine theta is this altitude H, is this dotted line. If B is less than that dotted line, no matter where I put B, no matter how I hang B up here on this little hinge, I would never get a triangle. It could never make it back down. So that's the no solution case. For us, it was going through the math and realizing that when we hit inverse sine, it gave us domain error. The next one, this is the first one we did. If the side across from the angle is bigger than the other side, B is bigger than A, this is the only thing that can happen. This side is so big, I can just fill it in and drop it right here, and that's the only place it can go. So I can solve that triangle and get those answers. And now that leaves us with this last little video of the ambiguous case. There's a sweet spot in there. If B is bigger than H, but less than A, if it falls in that range, then there's actually two different triangles that I could get. Right, and up for interpretation, two different meanings. That's what ambiguous meant. Okay, if this side B, I could swing it inside and get this obtuse triangle, or I could swing it outside and get this regular acute triangle. Two different answers, so I'd have to list all three of the unknowns for this one, and all three of the unknowns for this one. So there's actually 6 answers for this problem. If I said, solve the triangle with this information, well, there's 2 different triangles, so we would have to list all the answers for each. Pretty tough. I'm going to give you guys a little checklist here at the end of these notes so you know when does this happen. When do I have to do the problem twice? Okay, let's take a look at it. So here's the first one. It says solve the triangle with this information. Okay, the first little red flag, like, am I going to have to do this twice? Is this an ambiguous case? Is it SSA? So let's take a look here. Angle A is 58 degrees, across from at 4.5, and the other side 5. Yes. Side angle. That's red flag number 1. Red flag number 2. Is the side across from the angle smaller than the other side? If it's bigger, we're good. We know it's just going to be a one solution case. But if it's smaller than the other side given, that's our second red flag. Uh-oh. And then the last red flag is, does my calculator give me an answer? From this stage of the game, 2 things are going to happen. Either it's an impossible triangle, this side is too small, or this side is fitting in that sweet spot and I'm going to get 2 solutions. How do I know which one it is? I'm just going to go ram it through my calculator, and if it gives me an answer, if inverse sine gives me an answer, then there's actually 2 answers. There's the acute and the obtuse. Okay? So SSA, the side across is smaller than B. That's fishy. Something's going on. This is that case where I can have 2 different triangles that have all the same information. 58 degrees, 44.5, and 5. 58 degrees, 4.5, and 5. 2 separate triangles with these 3 pieces of information. We have to solve both of those triangles. Okay. There's what I just kind of told you guys and what's going to be on that checklist. Side across is smaller. Calculator gives me an answer. That actually means there's 2 answers. So here's me setting up the law of sines for each one. 4.5 over the sine of 58 equals 5 over the sine of whatever that ends up being. Capital B is what it would be. And then I can go through and solve it for capital B by taking an inverse sine. Now here's where all the red flags happen. My calculator gave me an answer, 70.4. It was an SSA case, and the side across from the angle was bigger than the other side. Oh man, all 3 of them go through. That means there's 70.4, which would be this angle. But there's also the supplementary version. Supplement, 180 minus 74, 109.6, about 110. So this one is 70.4 for this triangle, but that same angle over here is actually 110, an obtuse angle. So now we're going to have to go through and do this whole problem as if that angle was 70.4. Then I'm going to have to come back and do the whole problem over again as if this angle, this obtuse angle, is 110 degrees. 6 answers for this one. Lots of work. So let's finish it up. Let's actually do that. Here is the given problem. Notice the information is the same, but there were two different triangles. We went through and did the law of sines and got 70.4 for this one, and then we got 110 for this one. Okay, I'm actually going to put this one aside. I don't like working with them in tandem, like at the same time, because it starts to get confusing. So let's see, from here, I know capital A, I know capital B. If you ever know two angles, well then you know the third one, because you can do 180 minus those two and get that third angle, capital C. Now that I know capital C, I can set up the law of sines again. I can say 5 over the sine of 58 equals C over the sine of whatever capital C is, 51.6. There's me doing that right there. 4.5 over the sine of 58. Oh, I think I said 5. I misspoke. 4.5, A over the sine of A, sorry, equals C over the sine of C. We can rearrange that. We'll do 4.5 times the sine of 51.6, then divide by the sine of 58, and we get 4.16. There's our three answers, capital B, capital C, and lowercase c, for that first one. But now we're going to come back and we're going to do the exact same steps, but we're going to have 110 as our capital B. So I'm still going to do 180 minus 58 minus 110 to get me my other capital C, 12. I'm still going to use the law of sines with this capital C, 4.5 over the sine of 58 equals C over the sine of capital C. But this time, I'm going to use 12, because we know 12 instead of that 51.6. And we solve it. So we got 6 different pieces of information. When you give me these answers, I don't want to have to comb all your work to find all 6 of these. So I would like a little answer key from you. And in your answer key, I only want new answers. Like, I don't want you to give me capital A. I know capital A is 58. It was given to me in the problem. Don't give me that in your answer key. In your answer key, I want the new one. And make sure one goes with the other. You're not intermixing the two, because, right, we got 3 answers from the left side and 3 answers from the right. So here are my answers from the left side, all grouped together, and then 3 answers from the right side. Sometimes students start flip-flopping these, like 70.4, 12, 4.6, 110, 51.6, 1.1. They get them flip-flopped, and that doesn't show me you exactly know what these triangles are. So keep them in line. Okay, here's your guys' checklist. We've seen it now. We have the 0 cases. We have the 1 case. We have the 2 cases, the ambiguous case. How do I know when my answer will have 2 solutions? Here's how you know. Red flag number 1. Is it an SSA case? Do you know 2 sides, but not the included angle, right? The included angle is the one between them. We don't know that one. So side-side angle, or yes, that's angle side-side. That's red flag number 1. Red flag number 2, is the side across from your angle, you're only given one angle, is the side across from it smaller than the other side? Uh-oh. If it is, we have some thinking to do. If it isn't, if it's bigger, then just go do the problem. You'll get your answers. Your calculator won't tell you a lie. It'll give you the truth. And then finally, this last one. When you go through and you take the inverse sign, does it say domain error? It says domain error. That means there are no solutions, no triangle. If it gives you an answer, that actually means there's 2 answers. There's the acute version and the obtuse version, and you have to account for both. I hate the law of sines. There's a lot more thinking to it than normal. Law of cosines is ugly, but it works every time, and I don't have to go through this. But with the law of sines, we have to be aware of, do I want the acute answer or do I want the obtuse answer? My calculator will only ever give me the acute. Here's the rest of your stamp. You guys already did some problems from the law of sines, but I omitted all the ambiguous case ones. Well, now I'm bringing them back with some word problems. So page 518, 1, 5, and 9, 17 through 22 all, 25, 26, 27. I will stamp this on Thursday or Friday. So get all your questions ready, try them all out, and then you'll get those stamps. All right, moving on. Good job, Trey. See ya.